I've got a question. We've done pretty much everything except right here when it's stretching.
Can I please compliment your diagrams? These are awesome.
Okay, thanks. And is this spring or is it kinetic? Because I know it's stretching.
Okay, so you know it's stretching, so then why do you feel conflicted?
Well, can spring be an energy? A spring force?
Can spring be an energy? What are the three types of energies that we talked about? They're still on the board, you don't have to memorize them yet.
Mechanical.
Okay, so mechanical is an overall form of energy, and we broke it down into three types.
So potential, kinetic, and spring. Gravitational.
Okay, so it's kinetic, and then you have potential. There are two forms of potential. Two forms of potential are
spring and gravitational.
That's poorly done,
yes.
Andrew.
Okay. Can I free you of the need to have something memorized the moment it comes out of my mouth? You don't. You can look and refer to your notes. You don't have to memorize it immediately. Okay, so your question is...
This is like as low as it's going to get.
Okay, this is as low as it gets. Stretched out. So the stretched out means that it is using what type of energy?
Gravitational.
Okay,
it's
gravitational.
Down on it.
And just completely destroy the purpose of this lab.
But then we should be talking about what's pulling down on it. So right now we're talking about what is stretching. Okay, but this is what you're going to do. So you said it's stretched right now, right? So you feel like it should be what?
Spring.
Okay, so you feel like it should be spring. So our equation for spring is what?
The egg is not going to make stretch that much.
U equals 1/2 kx squared.
Okay, U equals 1/2 kx squared. K stands for what?
The constant.
Spring constant.
Spring constant.
Okay, and X stands for what?
The distance that it's fallen.
The distance that it's falling?
Or the distance that it's like stretched.
The distance that it is stretched. Okay, so that means in order to use that equation or to have spring potential, we have to have K and we have to have X. So do we have a K?
Not yet.
Will we have a K?
Yes.
Is there a K that exists at this time?
Yes.
Is there an X that exists at this time?
Yes.
Okay, because it is stretched. Okay, so that means yes, we have potential from the spring.
Okay.
So then the next question is, do we have potential from gravity? What's the equation for gravitational potential?
Mass times gravity times height.
Okay, chime in anytime. Mass is the mass of what?
The egg.
Okay. Gravity, do we have that?
Yes.
Height, do we have that?
Yes.
Why do we have height?
Because that's the distance of what it's at.
This is height?
No, this is the height.
This is, well, that's the height of the tower. Are we getting the potential of the tower? Or are we
We're
getting
seeing
the
how
potential of
long
the egg?
the egg.
Okay, so the potential of the egg means it is the height of the what?
The egg from
the ground, exactly. Absolutely.
I thought that'd be from the top.
It is on a different diagram. Which diagram is the height of the egg at the top? There. Okay, so this diagram is using the height all the way to the ground from the top because that's where the egg is. But here, where's the egg?
It's the bottom.
It's at the bottom. So is there still going to be a height here?
Yes.
Yes, why? Because we don't want what to happen.
It crashed and break the egg.
It crashes and breaks the egg. If it crashes, is there a height?
No.
No, but we don't want that to happen.
But right here, its velocity is 0, right? Because it stopped. The spring force has stopped it. So that would be potential because it's going to go back up.
Okay, wait. That's two different questions. So the first question is it stopped? Yes, it stops because the spring is activated and it's going to pull it up, but it hadn't pulled it up yet. Okay. So the velocity has to go to 0 because it's got to turn around and go back up. Exactly. So when it's all the way at the bottom, is there kinetic?
No.
Well, not when it hits the ground. Well, we're not going to go there. It's not going to hit the ground. So it's going to stop before it hits the ground, so that means it won't have kinetic, but it does have potential from what? And from what else? No. What are the two types of potential?
Oh, spring and gravitation. Oh,
Spring and gravitational. Okay. So what this diagram needs to have on it, it has potential energy. That's generic. Be more specific. It has potential potential energy caused from spring and from gravitation.
Okay. And then it says we need to have the form of energy of the bungee. So this would be
this potential energy that we said is caused from spring and from gravity. Gravity potential energy is caused from the fact that gravity is pulling on it. Spring potential energy is caused because what is pulling on it? The egg's not pulling on itself.
The gravity, right?
Gravity pulls it which way? Okay, so that's gravitational potential.
And then the recoil.
What's pulling it up?
The stretch.
The spring potential, the fact that it is stretched, is pulling it up. Okay, so that's the bungee. Okay, so don't overthink that. When they're just referring to the bungee as a big unit, part of it is the bungee is what is giving the spring force.
Now,
Yes.
the first diagram, you'll see at the top is potential. Does it also have gravitational potential?
Okay, well, this is because you guys need to be more specific. Potential is, there are two possibilities for potential. Spring and gravitational. Which one is occurring here?
Gravitational.
Gravitational. So that's what this needs to say. Okay?
This would be spring potential.
What has to happen in order for there to be spring potential? Okay, motion gives me what kind of energy?
Kinetic.
Kinetic. So then, is it in motion right now? So that's not what's going on. So in order for it to have spring potential energy, it has to have something, it has to have a spring. Does it have a spring right now?
It's connected, but it's not.
It's connected, but it's not being used, so it's irrelevant.
Okay.
Okay. This, right now, this rubber band is dangling in the air, right? Does it have the potential to move? What would happen? If I did what? If I pull on it. But right now, does it have the potential to move? No. It could fall, but that's not spring potential. In order for it to have spring potential, it must be stretched. Okay, so since we're here, let's look at the second diagram. This has potential energy, so we need to define which type of potential energy it has right here.
Spring.
Because what is happening?
Because it's being used and
It's being stretched right here?
It's
Okay.
not being stretched yet.
It's not being stretched yet? So then that means what type does it not have?
Spring at that
Right.
point.
At that point, there's no spring. Okay, does it have gravitational potential energy?
Yes.
Yes, because it's still falling and there's still what here?
Height.
Height, exactly.
The height is when it's already, when the spring's already it's already activated.
Absolutely. Okay, so then we have our conservation of energy. It's going from what form at the beginning?
The potential.
Okay, caused by
Gravity.
Okay, label that because we keep having to rethink this. Caused by gravity. As it's falling, it transfers into a new form. Once it gets all the way to the bottom, it's going to be another form. Okay, so you're labeling this transformation as it goes down.
Okay.
What about the overall quantity? Is it changing? No, it's just changing its format. Because I'm lazy.
Okay.
There.